And I think we should be live, and we'll wait just a minute before we actually get started. But I was just
Sounds
commenting
good.
how I really like Jacob's bison painting behind him. I think it's awesome.
Bison are lovely. If any of the people in the audience have been to San Francisco ever, they should go to Golden Gate Park. There's a fun bison surprise there.
I'm surprised how many people don't know there's bison in there when I bring it up in the Golden Gate Park. I'm like, yeah, there's just bison. I mean, they're like not. It's not quite like Yellowstone,
Yeah,
but it's there's a lot of bison you can go see, which I think is really cool.
for sure,
I
for sure.
I did go to Yellowstone this year and I saw bison over there too. So big fan.
Very cool.
All right. So we can go ahead and get started here. I'll just do a quick little intro. My name is Sage Elliott. I'll be the host for today's live fireside chat from Union. At Union, we help orchestrate the processes required to build and train complex and dynamic machine learning and data products at scale. So if you're interested in just learning more about what we do, you can check out links in the description. They're at the bottom. All the links for Jacob's awesome stuff is before that. So check out his stuff too. We'll get to that a little bit later. And if you want to always give both of our open source projects at GitHub Star, I know we always appreciate that for our open source work. Jacob gives a thumbs up. And today we have Jacob Marks from Voxel51 to talk about how LLMs, or large language models, are changing computer vision, which I'm really excited to hear more about your take on this. And if you're watching this live, say hello in the chat. It's always fun to kind of see who's watching. And if you also want to share where you're watching from, I think that's also really fun as well. And if you want to go a little bit further, you could also share a little bit about what you're building or learning, probably around AI if you're here. And feel free to ask questions. We might not get to all of them or anything like that, but it's fun to kind of see what people are thinking about. And all right, so Jacob, could you provide a introduction and let us know a bit more about your background and a little bit about what you're currently working on, even though we'll probably dive way deeper into that later.
Absolutely. So thank you for having me, Sage. It's great to be here, and very excited about what you and the Union AI team are working on. I know that so many of our users, open source and otherwise, are really huge fans of Flight and other things that you guys are working on. I'm a machine learning engineer and developer evangelist at Voxel51. I'll give a little bit more of a background on Voxel51 later on, but I came to Voxel51 and machine learning by way of physics. So my background is actually primarily in physics, and I got into machine learning through kind of an unusual route, although nowadays there's a lot of people who go from physics to machine learning. But I really primarily work in the computer vision side, and that is my exposure to large language models, and the way that I approach them is really driven by applications in computer vision and enabling these models to see and understand the world rather than focusing on a chatbot first approach. I'll pause there and we can continue.
That's awesome. And what got you first into computer vision? Was that just like something you stumbled upon during like while you were, I don't know, looking to build something specific or?
Yeah, yeah. So I uh, during college and right after college, I did a little stint as an imaging engineer, like a computer vision position at a medical imaging company. So it was using mostly classical techniques, so not a lot of machine learning, mostly like edge detection and blurring and things like that. But one of the things that stood out to me from that experience, aside from the fact that it was really impactful and there's just so much work that can be done in processing medical images and like wildlife and conservation images and using computer vision in order to make a positive impact in the world. The problems that are posed in computer vision are often very geometric and spatial, and that really jives well with my physics underpinnings. So it really hit home in a way that I was not expecting and felt it resonated with me a lot. So that's something that has definitely kept me excited and has really directed my intuition with regards to what problems to work on and what things are cool.
That's awesome. Yeah, I love the computer vision industry is something that got me into machine learning as well. And I just loved like all the applications, even like 5 years ago, the stuff you could do with it and where it was being used, like in healthcare and agriculture and all these different industries that people may not always think of. I found it really exciting. Like just like you said, it was like you could make a positive impact with that technology, like right at that time, which is really, really cool. Awesome. So our main topic today is how large language models are transforming computer vision. I think it's a really exciting topic. Before we dive really deep, I guess, into the transformation piece that LMs are providing to computer vision, let's maybe do like a high level. I'm assuming most people here know what a LLM is, and probably kind of have an idea what computer vision is. But just to make sure everyone is kind of on the same page, maybe we could just kind of recap what is a large language model and what is computer vision.
For sure, for sure. And I'll caveat this with a lot of this, especially with the large language model side, is rapidly evolving. So everything from what the latest developments are and the transformations to the definition of a large language model itself is kind of in flux. So when I think about large language models, and if you look online and you try to find what the rough consensus is, uh, large is a part of it, and that's somewhat flexible for different applications. Some people consider 100 million parameters as large. Some people consider 7 billion to be the cutoff for what is like actually large. Some people talk about larger than that, 70 billion, or things like Palm, which is 340 billion parameters, as being one of the big large ones. But it's pretty flexible depending on the application. The general idea is these are very large, so they have a lot of parameters, so that there's a lot of representational power, and oftentimes they're what's called underparameterized. So there's a lot of hidden information nestled within those parameters, and there's a lot that you can do when you fine tune it. So there's a lot that can be still learned if you try to train it on specialized data and stuff like that. The language means that it is useful for, depending on the model and what data it was trained on and what the specific objectives were. It can be useful for things like being a chatbot in English, or in some other language, being an assistant or code completion, or a variety of those tasks. And today, one of the big things and part of the transformation that we're going to talk about is multimodal large language models, which we'll get to soon. But stepping to the side for computer vision, which historically has been a very distinct discipline from natural language processing, and the large language models, which are an offshoot of that, or are kind of an extension of NLP in some regard. Computer vision is a field concerned with helping and understanding how computers perceive the world. So things like classification. So if you have an image and you want to classify it as a dog or a cat, or if you have an object and you want to detect, find where in the image a dog is, or where in the image a cat is, if you want to do things regarding individual pixels in the image, so segmentation tasks. So not just saying, okay, this is the box that contains the dog or the cat, but these are the specific pixels that are dog, and these are the specific pixels that are not dog, and doing that on a class by class and pixel by pixel basis. And those things are cool in and of themselves, but the real value there is once you've done that, once you have processed these images or videos or point clouds, which are the data processed form, the representation of LiDAR and some types of radar and things like that for self-driving applications, then you can, after doing these machine learning and other computer vision tasks, you can take those insights and use them to make decisions in the real world about what to do. So whether to turn left or turn right, whether somebody has a tumor or not, and things like that.
Awesome. I think it's a fantastic explanation for both of those things. So I think if people weren't already pretty familiar, they kind of have an idea of what LMs are, how they're. I mean, I'm sure people have at least seen news on LMs, even if you haven't used something like ChatGPT. I'm sure you've heard about it by now. All right, so let's dive into how large language models are transforming computer vision. What are some of the transformation like we've seen happen in the space with the rise of LLMs, and kind of maybe where do you think that's going? Or those could be maybe two separate questions, but like what do you see right now transforming the space?
Yeah. So again, huge caveat, this is all changing really quickly. So tomorrow there could be something completely different that comes out. And in fact, today there was something completely different that came out. There was Gemini from Google, which uh, one of the main benchmarks, the massive multitask language understanding benchmark, which is like academically how people judge the performance of a lot of these models. This Gemini model, the large one, which is going to be released next year, it hit state of the art on 30 out of 32 of the tasks on that. So it actually beat human level performance on a lot of things, which is somewhat unprecedented. So things are changing really fast. But in general, the transformations that we're seeing, and that the way that like to think about them and categorize them is in kind of two buckets. One is as using language models as delegators, as orchestrators, in a similar vein to what you guys do, as dispatchers, and as like executive engines for a lot of other specialized models, and that could be vision models and audio models and otherwise. So kind of like a centralized brain that decides what planning to do and how to compose things together. This can be how to write a program that calls models, or how to decide the order in which to do things. And we can talk more about these things in the specific projects that are doing those. And the other area is in enhanced flexibility for a lot of vision tasks. So there are two examples which we can talk about there, which I think are super cool. One is using things like these GPT-4 Vision or Lava models in order to basically take the natural language understanding, the like open world knowledge of this model, and combine it with visual actions essentially in order to do things that are just super cool and just fly off the screen. So, for instance, sketch to HTML, or like sketch to code generation, or without having to fine tune or do a lot of prompt engineering, using GPT-4 with Vision in order to control your browser, things like that. So that's one category, and the other category there is things like Otter HD. So these models which are able to take the natural language understanding and computer vision understanding, and essentially have the flexibility there to perceive and understand really high resolution images in a way that has not ever been done before. So we can dive into any of those you'd like. There's so much going on. It's just it can be really overwhelming.
Yeah, that there is a lot going on. Just like you said this morning, I even just saw the headline. I didn't dive into the benchmarks of Gemini, and I was like, oh, I wonder if Jacob's gonna bring it up. Like, and I love that you already dived in. Yeah, I mean, I think those are all really cool use cases. Is there one that you particularly find like more interesting, or that you're really excited about out of the things that you mentioned?
So from an academic perspective, and we've been seeing these dispatchers and delegators for the past like 5-ish months now, maybe 6 months, depending on when you set the initial cutoff for these things. But some of the examples for this are ViperGPT and HuggingGPT and VizProg. So some of these are papers that have been at CVPR and ICCV. So CVPR is the conference on computer vision and pattern recognition. ICCV is the International Conference on Computer Vision, and then NeurIPS, which is happening next week, is the like premier conference for most machine learning stuff. It's neural information processing systems, and all of these projects have been accepted, and in some cases were spotlights or won best paper at these conferences. A lot of these are taking the idea of using the LLM as the like the thinking engine, like the brain, and then deciding what models need to be called, and so that you can split up the reasoning from the specialized domain, or like model application. So in the past, when you had these types of tasks like visual question answering, where you take an image or a video and you need to understand something that's going on in there. So you ask a question like, how many people are in the image, or what is the expression on the person's face, or how many muffins does each kid have to get for it to be fair? Or you can get arbitrarily complex with the questions that you're asking, and this is more complicated than captioning, because in captioning, it's basically like you're asking one question, but visual question answering is like there could be any question effectively. So this is like a somewhat open world category. And then you get to more complicated multimodal tasks like grounding tasks. So when you ask questions specifically about the locations, respectively, of things within images, and ask the relationship between images, and so on and so forth. Oftentimes in the past, people tried to train end to end a single model that would do the reasoning and the vision work internally, and then we just spit out an answer for you. So it would decide, by going through all the neurons, the different layers, that the answer was two, or the answer was the elephant is an African elephant, or whatever else it is based on the question that you asked. But the approach from a lot of these new techniques is essentially to say, okay, instead of trying to train one end-to-head model that is good at reasoning and at vision, or at audio, or whatever the other specific modality is, why don't we decompose the problem into the reasoning part of it and the vision part of it, and write a little pseudocode program, or in some cases an actual program that runs and compiles and then is executed, in order to split up the reasoning. So we can say, okay, we need to do an object detection task for people, and an object detection task for muffins, and an object detection task for this, and then we need to use a mathematical library. So whether it's just NumPy, or you actually need to use Wolfram Mathematica or something else, and then we combine the answers, and we spit out we like pass that into our like reasoning and language based approach, and then we can actually respond to the user using natural language with all this information that we've gained. So that is the basic idea behind a lot of these techniques, which are really cool. They're not necessarily novel anymore, but I think that we're going to see so much more in that regard as these models get better and better, and as the speed and the latency improve. So oftentimes one of the big problems with these approaches is that because you are needing to step back and decide what actions you want to take and how you want to split things up, and then kind of aggregate all the results and then respond, it takes a while, and there's also a lot of steps which can compound errors and compound all this latency and cost, and also can compound potential uh, if you have like prompt issues, like if the model doesn't like decides not to respond, it says this is actually like this is out of my jurisdiction. I don't want to do this. And you can get more and more of those things as the number of steps increases. But we're seeing these types of things get more and more robust and faster and cheaper. And I think that those approaches are going to be really pervasive over the next couple of months.
Yeah, it's amazing seeing. I've seen some examples of this with startups around like robotic navigation, for instance. Like you mentioned grounding, like knowing where objects are, and like what's in the image and how to move around things and go to destinations. It's so cool seeing some of the stuff that people are doing with that technique, and like bring it into like a physical object that can better navigate like the real world, and these really really complex situations, even though we don't think they're complex. But seeing stairs, and how do you go upstairs, like all these different things, where are they, like how do you step onto it specifically. I think it's really amazing, and I'm really excited to see what comes out of all this.
Totally, totally.
um so you've been doing some awesome work with LMs and computer vision um at Voxel51. Can you tell us a little bit more about what you've been working on?
Absolutely. So Uh, for a little bit of context, at Voxel51, we are a data-centric AI company. So our goal is to bring transparency and clarity to the world's data. We want to be the place where AI work happens, and really give people the tools to better understand their data, and to curate higher quality data sets so they can train better models. That is what we work on. So we are the lead maintainers and developers for the open source project 51, which Sage is going to put the link to in the notes for the show. Um, the things that I work on regarding large language models and computer vision, uh, a couple months ago, we had our last fireside chat and we talked about Voxel GPT, which was our usage of large language models as essentially a query engine for our 51 query language. So we took the LLM capabilities and we fed in all of the particular knowledge of the schema of 51 data sets, so the way that people actually structure their computer vision data in a data frame like object in our tool set, and use knowledge of their natural language query plus the data set in order to turn that into a working code that filters the data set for them. Um, that's cool. You can still try that out for free on try.51.ai. It still exists. It's going strong. The thing that I'm working on currently regarding large language models and computer vision is actually something that is more trying to use language models to improve the state of the art for computer vision tasks. So I mentioned that something we saw recently is Otter HD, this model, which is a fine tune of Adept's Fuyu 8B, which basically the main idea is it doesn't actually have a vision encoder explicitly in the model. It just passes in all the tokens for images, and in the way that it does this, you can have flexibility in the number of tokens representing the image, and it treats them in a somewhat similar sense. So essentially that means you have control and flexibility over the resolution of images, and they're all treated relatively similarly so that you can get to very, very high resolution images and get super good understanding of those high resolution images. Uh, the point there is just that people have seen that large language models can improve the baseline on a lot of these computer vision tasks, and the same is true for things like visual question answering, which are more multimodal tasks. But the idea is there. What I'm working on in particular is people recently have gotten really creative with the way that they approach retrieval for text. So retrieval augmented generation is huge these days. That forms the backbone for long-term memories for a lot of these large language models. And now people are even talking about multi-modal RAG, RAG being the acronym for retrieval augmented generation. Um, the the idea is you take your vector database, which has some encoded vectors representing your documents or chunks of documents in your database. You take the user's query, maybe process it in some way, and you compare that to the embeddings from your database to determine what relevant documents or chunks of documents to feed in as context to the model. And that is used for generation, so to help the model to generate some text at the end of the day. But it doesn't always have to be for retrieval. In order to improve results for these things, people use a technique called re-ranking, where they take their candidate results they've gotten from this initial retrieval stage, and then they use a cross encoder most of the time. So they take in the embedding of the query and the embedding of the document, or they take the raw text actually of the query and the raw text of the document and compare those to each other with a cross encoder. And that turns out to be more computationally expensive, but also more exact than a lot of the embedding multiplication, like taking the dot product to cosine similarity of the embeddings themselves. So the main, like the gist of it there is that people do re-ranking, and they've figured out how to do really good re-ranking to improve the quality of these retrieval techniques for text. But there hasn't been as much work historically on re-ranking for image-based systems. And the idea that I'm pursuing right now is using these multimodal or vision language models essentially as re-ranking engines for your image-based retrieval tasks. So forgetting about, and there is of course the possibility of using this in multimodal RAG, but just in general for image retrieval, using the state-of-the-art image retrieval models and techniques as the starting point to develop your set of candidates. And once you have those candidates, to pass the images in to your multimodal model and to be able to do some re-ranking on those and to evaluate the results at the end of the day. So I know I just gave a lot of stuff, but that's what I'm working on.
That's awesome. Could you touch on what multimodal RAG is?
Absolutely, absolutely. So multimodal RAG is the idea that oftentimes you may not just want to pass in language or text data. So uh, in the way that humans look at the world, when we read textbooks or we read books or we watch TV, we're seeing text and images together, and oftentimes that text and image combination and whatever other information that we are seeing is specifically curated for us to be combined in that way. For these models, which are very, very high performing and have really good generalized ability to understand the world, uh, we have reason to believe that being able to feed in relevant or curated data for not just text, but also for images and potentially other modalities for these models that do support other modalities would help the models to actually generate the best results at the end of the day. So if you are able to feed in relevant images in addition to relevant text, and so you do the retrieval on your database of not just text, but also images, and you feed in sometimes they're connected, the text and images, sometimes they're not, and you're just feeding in the most relevant text and the most relevant images, and then the model's able to infer from all of those things and from its all the information contained in its parameters itself and the question you're asking it, what a good result would be. So one example of why this could be useful is retrieval augmented image captioning. This is just a super basic example, but this is something that I think gets the point across pretty well. So if you give one of these models an image of a car and you ask it to caption that, it's probably going to give you a fairly basic caption. It might give you a really just really in-depth description, but it's not going to know where to take it per se. It's not going to know if you want to talk about the color of the car, the price of the car, what else is going on in the room with the car or on the street with the car. It's just not going to know all of these details. But if you instead feed in a bunch of examples of image caption pairs that are specifically cars and the captions of those cars. So if you have a database of car listings and the captions for those cars that are listed on your website, you feed those in, then it can do a much better job of deciding what the caption should be for the new image. So you know, in that case, you're doing image caption pairs, but in general, it can be any combination of documents from multiple modalities.
That is really cool, and I'm sure we're going to see way more of that. I remember working on like a image captioning project again years ago, just talking about how fast everything changes, and it was hard to get a good caption for like specific things like that, like a specific car or items in there. So you could only do kind of more high level general, like there is a car on a street or something for good results. Awesome, and I know we're getting close to our time here. Could you talk maybe a little bit about what your development stack looks like right now for combining LLMs and computer vision?
Yeah, I
And
I don't think
I'm
that my
sure it's all
development
over.
stack is yeah, I don't know if it's stable yet, and I also don't think that it is probably the most state of the art development stack that anybody has. So I won't bore people in the audience with the details. But what I will say is that my approach to development with LLMs and otherwise is data centric. So I know that there's a lot of talk of some actually validated, some has come into question about the emergent properties of large language models and the fact that when you get these huge number of parameters in a model, you have this qualitatively different behavior than you have for smaller models. Um, that may be true in some cases. I think that the jury's still out on where that holds, where it doesn't hold, and there's a lot of work that needs to be done to flesh out those details. But the important thing for me is that there are still a lot of scenarios where digging into the data and focusing on small problems, like starting really small and understanding how things generalize, is much more important than just throwing huge models at problems. And so my approach is very much focused on the data.
Awesome. I think that's a great place to start with any model. Focus on the data. All right. So I know we're nearing our time. Can you tell us a little bit more about Voxel51? I know you mentioned a little bit. Anything else you want to kind of shout out or encourage people to check out? And you said I would include links in the show note. They're already there. So if you're watching live on YouTube, you can go check out the links to Voxel51 and the links to where Jacob posts as well.
Awesome, awesome. So I'll just leave you with one additional thought for 51 and Voxel51. So for a while now, for a couple of years, we've had this toolset 51, which is an open source toolkit for curation and visualization of a lot of data in different modalities, and it's really flexible. It's really versatile. You can use it through the Python SDK, which is programmatic access to your data, as well as via a UI. But one thing that we heard a lot from a lot of our users is that there's just so many different directions the field is going in, that there's so much flexibility that they needed, so that we actually, instead of building all the different features that everybody was interested in for the different tasks and data types, we decided to instead focus on building out a plugin system that makes it customizable. So that's what we've done, and we have a really, really awesome plugin system that has been you know, growing, and the ecosystem has been just exploding over the last couple of months. And regardless of the specific task or workflow or use case that you're working on or modality, 51 is now able to be extended and applied to that in just a few lines of code. And we even have a plugin builder plugin in the app. So it's just super flexible. Highly encourage you to to check it out. And even if the things that you see specifically on the website for 51 aren't exactly what you need, in just a few lines of code, you can make it happen.
Do you have a plugin builder GPT yet?
Not yet. Not yet. Maybe that's
um,
next.
yeah, it might be. It might be. All right. One last question is, what are you looking forward to in the AI field?
So the thing that I am most looking forward to, I think we've seen a lot of focus recently on these foundation models and making models bigger and better and all that, but we've also seen some work on efficiency. Some of this is, whether you're talking about clip models or huge large language models and the fine tuning of them. A lot of work's been done in quantization and in speeding up the fine tuning process for these things. And then there's a lot of work on the ML ops side around making it easier to actually gather the data and to train a model without really needing to write too much code. I think with putting all this together, we're going to see a lot more, uh, I think, open access to, and I would even say just completely universalizing the idea of customized intelligence, and it's going to be real time at some point soon, hopefully real time, and you'll be able to do it basically without writing too much code. And I'm super excited for people to have this democratized access to customized intelligence.
Yeah, I think it's going to be an incredible time. Just like you said, all these new foundation models coming out is really exciting, and all the tools we see in the space coming out to make it easier to build an AI application, not just get the model, but put that model out there, consume data, make decisions based on it. I think it's really exciting time. One other question that came in from an audience is: do you think the computer vision hype um, is already happening with multimodal LMs right now? I think they meant like kind of like how there's like, the big LM hype that is happening or has been happening. And do you think there's going to be a larger computer vision hype happening soon as well?
Yeah, I don't think that we have nearly hit our ChatGPT moment for computer vision yet. I think that there's a lot of work and there's a lot of activity in multimodal large language models or vision language models these days, but I think that that's still riding the coattails of the LLM wave. I think that once we have our ChatGPT moment, once there's some advance or things become more that little bit more efficient to actually make things more accessible to everybody for computer vision. And we find that killer use case, the one killer app, that we're going to see another explosion.
Yeah, I agree. I think it's the combining of all these things together is going to drive something really, really cool. And I wouldn't be surprised if you're the one who built it, Jacob. So
Or you.
All right. Before we close out, is there anything else you want to shout out? Any upcoming events you're going to be at or doing that you want to uh, let the audience know about?
Yes. So my team and I will be at NeurIPS, which is happening next week in New Orleans. So if you are there, please come say hi. We're going to have a really big booth. We're a platinum sponsor there. We're happy to talk about data-centric AI, any of this LLMs meet computer vision stuff that we were talking about today, or just anything in general with the future of AI. So please come by and say hi if you're there. If not, feel free to reach out on LinkedIn. And thank you, Sage, so much for having me. It's really been a pleasure.
Thank you so much for coming on and being part of our first Union AI fireside chat. I'm really excited that you are our first guest. It's always a pleasure talking with you. And definitely go check out the links in the description or go find Jacob Marks on LinkedIn. And also, you help run an amazing community as well, where you do a lot of events. I don't know if there's any more before the end of the year, but I definitely recommend checking out the Voxel51 community. You always have so many cool speakers on and talk about some amazing stuff there as well. So please check them out.
Thank you. Thank
And
you. We have one
get
tomorrow.
51. You have one tomorrow? Nice. What is it tomorrow?
Tomorrow's our data science and AI meetup. So we've got a couple of cool speakers, including the lead developer advocate from DeepSet, the makers of Haystack. So that's if you've heard of Llama Index and LangChain, Haystack is very much in that category of LLM chaining and building these atomic elements around LLM workflows.
Amazing. Yep. You heard it here. Go check it out. And with that, I'm going to go ahead and end the stream. Thank you again so much, Jacob. And thank you, everyone, for tuning in and for the people who said hello in the chat and people who asked a couple questions. So thank you, everyone. And I will see you all on the next Fireside Chat. Now there's going to be the